So complex numbers have a lot to them. And in the last video, we went through, we defined what an imaginary number was, we defined what complex numbers were, we did some basic operations with both I and also with complex numbers. So we're going to continue that in this video because there are a couple other things, operations that we can do with complex numbers that we didn't really have time to do in the last video, and I wanted you to really practice those before we did this. So here we go. So I need to review a concept called rationalizing a denominator. And what this means is that, and I'm not sure if you got this in Algebra 1, but sometimes when you had a fraction that looked like this with a square root in the denominator, and this is not imaginary, this is just, basic, some things that you would have learned in algebra. So in order to rationalize a denominator or a numerator, doesn't matter which, what you're trying to do is you're trying to write the fraction without the square root in the denominator. So the goal then is going to be no square root in the denominator. Okay, so that's our goal, is what we're going to do. So what we do is we multiply it times a form of 1. Right? A fraction, a form of 1 means 2 over 2 or 3 over 3, a form of 1, or square root of 3 over square root of 3 is just 1. All of these equal 1. Okay? So on this one, since it's the square root we're trying to get rid of, I'm going to multiply the top and bottom by the square root, and I get 2 times the square root of 3 over the square root of 9, because you multiply inside times inside. Okay? Well, the square root of 9 is just 3. So I would have 2 square root of 3 over 3. And that would be a rationalized denominator. But you can also do that with the numerator. So say, for instance, you started with the square root of 3 over 2. And the goal was not to have the square root in the numerator. Well, you just do the same thing. You're multiplying something times the radicals so that you don't have the square root or whatever wherever it is. So, for instance, if I had something, and I'm going to show it on the next screen, but if I had 2 over 3i or 3 over 2i, whatever, right, to rationalize this, or even just to divide it, would mean to have no I in the denominator. And so that's what we're going to do. So we're trying to figure out what we need to do, what form of 1, right, what form of 1, and we have to multiply times 1 because that doesn't change its value. What do we need to do so that we don't have an I in the denominator? So we're going to talk about that on the next screen. Okay, so the goal is going to be to simplify 3 over 2i, or in other words, rationalize it in a way so that there is no I in the denominator. So in order to do that, we need to think about what happens when we multiply things together. We know that if we multiply a plus bi, a minus bi, which you notice are both complex numbers. These are complex numbers without actual numbers, right? So if I multiply those together, a times a is a squared, and then minus abi, right? Abi, and then plus abi, so those are going to cancel. And then I have b times b, which is minus b squared I squared. So minus b squared I squared. Well, we know that I squared is what? I squared is negative 1. So negative times a negative is a positive, and I end up with a squared plus b squared. No I, right? So multiplying these two complex numbers together gave me something in the end that had no I in it. No I. And so if there's no I in it, that would mean that would be something that we could use maybe to simplify. So what we're going to do is find the conjugate. So opposites, in other words. And you'll notice that the conjugate of 1 plus I is 1 minus I. And the conjugate of 2 minus 7i would be 2 plus 7i. And 6 plus 25i. And negative 2i. But here's another one that you might not have considered. Negative 1 plus 2i. What's the conjugate of that? Well, the conjugate of that would be -1 minus 2i. And so what you'll see is it's the middle number, it's the sign in front of the imaginary part of a complex number that gets switched. So if it's positive, its conjugate will be negative. And what we're saying here are these two signs right here in complex numbers. All right. So for instance, if we wanted to simplify then, and this looks sort of like the other screen, I think I got it upside down, but what would be the form of 1? Well, the form of 1 would be the conjugate, and the conjugate of 2i is -2i. And so when I multiply across, I get on the top -6i over -4i squared. What's I squared? I squared is -1. So when I make that substitution, the top stays the same, but then I have a +4, no I. And so that's what you're after. So on the next screen, I'm going to do this one to show you how, this is how you divide complex numbers. You rationalize them. And to do that, you use the conjugate. So we'll do some examples over here on the next page. Okay, so 3 over 2 plus I. All right, so we want to multiply this by a form of 1. The form of 1 will also be its conjugate. So 2 minus I, 2 minus I, and then multiply across. It's hard to see. All right, so I have this on the top, just for clarity. And then on the bottom, I'm going to have 4 plus 2i minus 2i, and then minus I squared. All right? So these middle terms are always going to cancel. If you multiply anything times its conjugate, you're going to end up with 2 terms, because the middle terms are always going to cancel. It's the why you're doing it. So on the top, I've got 6 minus 3i, and then on the bottom, I've got 4 minus a -1, which is positive. So this will be over 5. All right? So let's try this again. What if I have 5 over 2 plus 3i? Right? So I'm going to multiply times the form of 1. The form of 1 will be its conjugate. So it'll be 2 minus 3i. Right? So I multiply on the top. I have 10 minus 15i over 4 minus 9i squared. What happened to the middle terms? Well, I don't need to write them because they're always going to cancel. So this is going to be 4 plus 9, which is 13. So I have 10 minus 15i over 13, which can be written like this: 10 over 13 minus 15i over 13. These are equivalent fractions. So here are a couple of problems to try on your own, and we'll be doing quite a bit more of these in class when you come. So please attempt these problems, at least write them down in your notebook, and we'll do them. In fact, if you wanted to, when you came to class, you could go put them up on the board and try to work them. I'd love that. Anyway, I'll see you guys in class.